Rheumatoid arthritis, one of the most prevalent autoimmune diseases known for the joints. Now, if you're a smoker, if you have a genetic predisposition to RA, or unfortunately females, you guys are more susceptible to RA than us males. But it's very common in society. Simple things: pain, stiffness, swelling of the joints are just key local signs that you may have arthritis. Now, there are a lot of drugs out there to treat arthritis, but not all of them work. Some people do not respond to any drugs, and some people who go into sort of remission stage, only about 10% of them actually maintain that, and a lot of them relapse. Now, a lot has been known about RA for a long time, and a lot has been known about the cells that work in RA. But frankly, not a lot of detail has gone into it. So the aim of my project is to look at one specific immune cell that could be the key to tissue homeostasis and resolution of rheumatoid arthritis, and that are the synovial tissue macrophages. Now, I've been looking at biopsies from distinct populations, from remission, from active with treated, and active naive, which are untreated patients. Now, we've looked at key markers so far that are present in macrophages, such as CD206, which is a mannose receptor, and we've looked at other key markers as well. One of the big ones that is coming up and has been shown in a lot of mouse literature is MERTK. Now, that is a receptor on the surface of a macrophage, and what that does is it acts as a link to those cells, the dying cells, to help engulf and to eat those cells, and that reduces inflammation, resolution of inflammation and tissue homeostasis, and also helps with remodeling. But in order for those two to bind, from the macrophage and the dying cell, there needs to be a bridge. Now, the bridge that we're looking at is called Gas6. A lot of mouse work has been done to show that overexpression of the MERTK and the Gas6 ligand completely obliterates rheumatoid arthritis or collagen-induced arthritis in mouse models. Nothing's really been done in humans. So my aim is to investigate the characterization of these synovial tissue macrophages and how the effect of Gas6 stimulation on these cells, along with a pro-inflammatory stimulant, affects the pro-inflammatory response. On the far side here, you can see a distinct image. On the left-hand side, you can see a pro-inflammatory stimulant and a pro-inflammatory stimulant with Gas6. Now, as you can see, there's a marked increase in pro-inflammatory cytokine production. Now, this could be seen in all joints, but we're just not sure. But as you can see on the right-hand side, in this double positive population, whereas the vast majority of remission show, there's a marked reduction in pro-inflammatory cytokine production. Now, this could be a key step to investigating how these cells react to this bridging agent, and whether this is key to the resolution of inflammation and overall tissue homeostasis and a better quality of life for patients. Thank you.